Okay, today's tutorials, we're going to work out these problems. We have 4 problems we're going to work out. The first one right here is auto check motors. So what we're doing today, all we're going to do today is we're going to write an equation, define our variables, we're going to decide whether we have discrete or continuous data, and we're going to, if we can, make a domain and range, and we're going to solve. So this first problem, it says auto check motors charge Paula $84 for an auto part plus $68 per hour that a mechanic worked to install the part. When Paula picked up her car, the bill was $628. How many hours did it take him to fix her car? So I don't know about you guys, but at least for me, I find I can always write an equation. I have no explanation for this. I can write the equation a lot easier than I can define the variables. So to me, it's really obvious that this is y equals 84 plus 68x. Because I only buy, what? Got blurry all of a sudden. I only buy the part once, so I don't have to multiply that by x, and I pay $68 per hour. So that means, so when I try to figure out what the x variable is, okay, I can always tell what x is because, my pencil needs to be sharpened, but I can always tell what x is because x is whatever is after the word per or each or for one or for every. So every time I see one, we're recording, every time I see one of these questions, every time I see those words per, each, for one, oh my God, seriously, I'm just doing this in pen. Every time I see one of these, I look for it. So $68 per hour, that means X is the number of hours. Okay? Now, when I look at Y, I think, okay, if I take $68 per hour, so $68 times however many hours it takes them to work, plus that $84, what is that going to tell me? What is that going to tell me, guys? The total cost? Right, it's going to tell me the total cost. It's going to tell me how much my bill is. Okay? So, what do you guys think? Do you think this data is discrete or continuous? Why do you think it's discrete? You're absolutely right. Yeah, they don't charge you. You're right. When you get work done in your car, they might charge you by like the quarter hour. I've seen them do like 8.5 or 8.25, but they don't really go much lower than that. So they do not, they're not going to like prorate you completely. So we're going to say that they're actually charging us per hour. In either case, this data would be discrete. Okay, so if the data is discrete, that means that my graph is going to be a bunch of dots and that my domain is going to be a list. Okay, so we know that in this situation, she spent a total of $628. So we can write a domain and range for this, okay? I have an equation, so I'm going to find my calculator, and I'm going to take this equation, which is, let's clear that, 84 plus 68x, and I'm going to look at my table. Now, if I go down to 0, that's saying, it says 084, so what that's saying is, before I do a single thing, he's got to buy the part. So before I even drive my car in there, they have to have the part. I have to have the part before they can do the repair. So my domain, even if I can have 0 hours, I could have 1 hour, 2 hours, 3 hours, and it says we work for a total of $628, right? Well, how many hours is that? 8. So all the way up to 8 hours. That's my domain. And it's a list because, remember, we're being charged by the full hour. My range is the Y values that go along with those. So if I work for 0 hours, that's going to be $84. If he works for 1 hour, that's $152, $220, $288, all the way to $628. Okay? So that's how I would write my domain and range for this one, because presumably once he fixes the car, he stops working on it, right? That's the plan. Okay, so what this means is it took 8 hours to fix the car. Okay, now if you look, we can actually look at other questions they might answer. They might say, okay, if it took him 5 hours to fix the car, how much money would it cost? Well, if it took him 5 hours, that would be $424. So this is the reason why a lot of people, like when we write an equation, a lot of people want to do this one. 628 equals 84 plus 68x. But this equation right here only answers one question. How many hours did it take to fix the car? With this equation, I can answer any question they give me. If they say it took 3 hours, how much did it cost? If they say it cost $764, how many hours did it take? I can answer any question they ask me. So when we write an equation, we always try to write the most general equation that we can, which in this case has a y and an x. Questions about that one? Okay. All right, let's look at the next one. This question is going to hit a little bit close to home this weekend. You are driving from Houston to Abilene at a constant rate of 70 miles per hour. Abilene is 357 miles away, for reals. Like, for reals it is. How long will it take you to arrive in Abilene? You will never arrive in Abilene. Okay, so what do you think my equation is? Y equals 70x, right? I could say 357 equals 70x, right? But if I do, again, that's that specific equation. We want to write the most general equation we can so we can answer any question they give us. And we always want to get in the practice of doing this, okay? Because remember, as algebra students, we want to be able to answer any question, not just the specific one they asked us, okay? So y equals 70x. X is whatever's after the word per. So hours, so it's number of hours. Now, we want to be specific, okay? We don't want to just say number of hours, because number of hours what? Like number of hours in a tanning bed, number of hours it took me to draw a picture? No, it's the number of hours traveled, okay? Number of hours driving. We want to be very specific, because that way we know exactly what we're putting in for that variable. So what is y going to tell me? Total what? Total miles driven? Okay, total miles driven. I like that. We're going to do another problem that shows you why defining this variable really matters. Okay, so we have total miles driven. So now I understand what's happening here. I understand the ins and outs of my equation. Now I need to think about my data. Okay, because, 70x. Y equals 70x. It says 70 miles per hour. What kind of data do we think we have? You're all so quiet. What do we think we have? Continuous. I agree that we have continuous data because I can measure miles, I can measure hours, and these things are going to happen gradually. It's not like every hour I suddenly teleport 70 hours ahead. Every hour, I'm going to gradually make my way through 70 miles, and the next hour, I gradually make my way through 70 more. So I would agree this is continuous data. Okay, now, what that means is I probably need this card. My domain and range are going to look like in one of three ways. They're either going to look like all real numbers, which almost never do we see a real-world situation that looks like all real numbers. Because, real-world situations happen in quadrant 1. We don't usually get to go negative. So we don't usually see this. This is not usually something we see in a real-world situation. We may see like x is greater than or equal to 5, or y is less than or equal to 7, or something like that, an inequality. And that's what we see when we have a value that looks like that. Now, we might also see one of those between statements, like x is less than, 5 and 15. X is between 5 and 15. And that's what we see when we have a starting point and an ending point. Which one do you think we have here? I think we have a starting and an ending point. I agree, because I'm starting in Houston, I'm ending in Abilene. So that means the miles I drive are going to be between, and the time I drive is going to be between Houston and Abilene. So if I look at my x values, that's my domain, right? If I think about the number of hours I travel, well, first of all, I got to figure out how long it's going to take me to get to Abilene, okay? So I'm going to put that equation that we made in there. Turn that so that it's actually visible. So 70x. And then I'm going to look at the table. And it takes me 357 miles. Now here comes a problem. When I look at the table for this data, at 5 hours, I'm 350 miles away. And at 6 hours, I'm 420 miles away. So I don't get exactly 357 miles. Okay? And I'm going to get real fancy and go 360. Well, 357 will work. Okay? So I'm going to have to, in this case, I have to actually solve it because I can't get a precise answer. I could, if the answer allowed me to, I could say between 5 and 6 hours or a little over 5 hours. But if we want to have a precise answer, we're going to say y equals 70x. Well, 357 is my y. And I'm going to solve. So 357 divided by 70 is 5.1, which is actually 5 hours and 6 minutes. I should not know this, but I do. So if I drive at a constant speed of 70 miles an hour, which, sad to say, I won't, because there's a billion little towns between Houston and Abilene, it would take me 5.1 hours, but it'll probably take closer to 6.5. It's going to be so boring. Okay, so my domain is all x values between 0 and 5.1 hours. And again, 0 hours means I'm sitting in my driveway. I haven't traveled at all. 5.1 means I managed to make it speeding through all those little towns, and I arrived in Abilene. Okay? Now my range, which is the total number of miles I've traveled, I will either travel 0 miles, which again means I'm sitting in my driveway, to 357 miles, which means I've arrived in Abilene. Okay? And the answer is it's going to take me 5.1 hours or 5 hours and 6 minutes to get to Abilene. Okay, what questions do we have about that one? We're okay with that one? Okay, let's skip on down to the last one because I want to do another time question with you guys so you can kind of get an idea of how they're different, okay? So this question also has to do with distance and time, but it's different. You're standing at the edge of a lake and your best friend is floating 38 feet away from you. Your BFF swims towards you at a rate of 2 feet per second. How long will it take for your BFF to be 6 feet away from you? So I have to draw a picture of this. Okay, so here's the picture. Here's the lake. And here's my BFF, Miss Walker. Okay? And here's me. And it's like a running through the field moment. And the music, la, 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 we're running towards each other, right? I'm running. She is running towards me through the water. She's bounding through the water to me, okay? Now, let's think about this. She is 38 feet away from me. After 1 second, is she closer or further away? She's closer. So that means the distance between us has decreased. So that means my equation is she starts 38 feet away from me, and every second she gets 2 feet closer to me. Okay? She starts 38 feet away. Every 2 seconds, her distance decreases by 2. Wait, every second, what? Yeah. Every second, her distance decreases by 2 feet. Okay? So in this case, when I write when I define my variables, x is per second. So x is the number of seconds traveled, we'll say. Just like we said, number of hours traveled up here, number of seconds traveled. And in this case, y means something different. Y means my BFF's distance from me. Okay? So you kind of see why having that precise definition matters. Because up here, this was the total miles I'd driven from my house. This is how far away she is from me, and it makes a difference in the situation. Okay? So now that we understand this, what kind of data do we have? We got continuous data. We have continuous data because time and because she's gradually getting close to me. It's not like all of a sudden she just like appears in front of me and I freak out. Okay? She's gradually getting closer to me. So we have continuous. Now again, let's look at these lists of values right here. I have, she goes off in one direction and never stops. I have all real numbers, or I have like a start and an end point. Which one do we have? We have a start and an end point, exactly. So we're going to have one of those between statements. So when I look at my x, number of seconds traveled. So I got to look at my calculator to get this one. So I'm going to put 38 minus 2x, and I'm going to look at the table. So at 0 seconds, she's 38. When does she get right up to me? The most she could travel is 19 seconds, because at 19 seconds she reaches me, and I guess she could like fake me out and just keep on running past me, but that's kind of not the point of this exercise, right? Even though I want to know when she's 6 feet away, look, this is BFF love happening. She's going to keep running until we meet, and then we're going to hug or something, okay? Or high five or do some kind of secret handshake, okay? So She could be running for up to 19 seconds. Or she could be at the point where she hasn't started running yet. Okay? My y values, if I look at them, she is anywhere from 0 to 38 feet away from me. Now, the question they asked is, when is she going to be 6 feet away from me? Well, she's going to be 6 feet away from me after 16 seconds. Okay? What questions do we have? Does this seem pretty straightforward? Okay. I don't think we need to do the last one. I feel pretty good about that.